Okay, page 39. The table below shows the cost of frozen yogurt for different numbers of ounces. Okay, so for 0 ounces, the cost is $0. For 1.2 ounces, you've got 60 cents. 3 ounces, $1.50, and 4.5 ounces, $2.25. So is the relationship shown in the table additive, meaning you're adding to get from the input to the output, or is it multiplicative? Are we multiplying to get from here to here? So 0 plus 0 equals 0, but 1.2 plus 0 does not equal 0.6. So this is going to have to be a multiplicative relationship. To get from one side to the other, from the input to the output, it's going to have to be multiplicative. Okay, so multiplicative is when you're multiplying to get from the input to the output. Additive is when you're adding or subtracting to get from the input to the output. Okay, so number 2, write an equation to show the relationship between the number of ounces X and the cost Y. Okay, so one formula you want to remember is Y equals KX. Okay, now what that means is this output, the Y, so first off, ounces is X. So we've got X over here, and we've got Y. Our cost is Y. So our output, our cost, is dependent on some number times our number of ounces, our X. So let's go ahead and substitute. Let's use, we could use any one of these except for 0. We don't really want to use 0. So let's use 150 and 3. So if we substitute, we have for Y, when Y is 150, $1.50, X equals 3. So instead of Y, I'm going to substitute 1.5 equals K times, and our X is 3. Okay, so 3 times something equals $1.50. So in order to get rid of this, we were trying to get K by itself. So in order to get rid of this times 3, we're going to divide by 3. Anything times 3 divided by 3 cancels out. But if we divide one side by 3, in order to keep this thing equal, we have to divide this side by 3 as well. So we've got K equals 1.5 divided by 3. 1.5 divided by 3. I can use my calculator for this. Turn it on. 1.5 divided by 3 equals 0.5. So K equals 0.5. So we have Y. So we can go back to this equation, and we can say Y equals 0.5 X. Now this should work for any of these X's we put in. 1.2 times 0.5. Let's pull out the calculator to prove it. So 1.2, let's move this. 1.2 times 0.5 equals 0.6. So yep, there we got our Y. When we put in our substitute our X, we got our Y. So let's do it for 3 just to make sure. So 0.5 times 3, and yep, it gives me $1.50. And 4.5 times 0.5, remember order doesn't matter with multiplication, gives me 2.25. So that's my equation for this relationship right here. Y equals 0.5 or 1/2 X. So you could write it like that, or since 0.5 is 1/2, you could also say Y equals 1/2 X. These are the same thing. 0.5 is equal to 1/2. Now, graph the proportional relationship shown in the table. Okay, so let's go ahead and make a chart for this. So we got X and we've got Y. So we know this is our formula. So when X equals 1, 1 times 0.5, y is going to equal 0.5. So when x equals 2, 2 times 0.5, we should know that 2 times a half is 1. And then 3 times 0.5, or half of 3, is 1.5. And for 4 times 0.5, or half of 4, is going to be 2. We can keep this table going. Let's just go up to 5. So 5 times 0.5, or half of 5, is 2.5. So this is our x. X is our horizontal, y is our vertical. So when x is 1, y is a half, 0.5. You'll notice this is broken into 2 sections here. So that's a half. So when x is 2, y is 1. When x is 3, y is 1.5. When x is 4, y is 2. When x is 5, y is 2.5. And you can see, since this is a proportional relationship, it would go through. Oh, when x is 0, also 0 ounces costs $0. So if we wanted to, we could put a line through this, and because it is a straight line, because it's a proportional relationship. Remember, proportional relationships are always straight lines, and they always go through the origin. The origin is the 0, 0, where x is 0 and y is 0. Okay, given the equation y equals kx, what is the constant of proportionality, k, shown in the table, equation, and graph above? Well, we already figured that out up here. Y equals kx, we substituted 2 of our values. When x is 3, y is 1.5. We got that from our table up here. When x is 3, y is 1.5. And we figured out, we divided both sides by 3, and we got k equals 0.5. Y equals kx. So for here, k equals 0.5. That's the constant of proportionality. K is what we call our constant of proportionality. It's what you multiply x by to get your y, or what you multiply your input by to get your output. Okay, number 5. Elijah helps his father with yard work. He can mow half an acre in 20 minutes. If Elijah mows at a constant rate, write an expression to find the constant of proportionality given x acres and y minutes. Okay, so we have x acres and we have y minutes. I'm going to put acres and minutes so I remember which is which. So x acres. So for 1/2 acres, I'm going to write it at 0.5. For 0.5 acres, we do that in 20 minutes. So in one acre, twice as many acres would take twice as much time. That would be 40 minutes. So we could have also used our k. This is a formula you want to remember. K equals y over x. So our constant for proportionality. So in this case, when y is 1/2, when y is 20, x is 0.5, and 20 divided by 0.5, clear, 20 divided by 0.5 gives us 40. So k in this case is 40. K is 40. So 40 times the number of acres is going to give us our time it'll take to do it. And you can see that if we doubled this, so for 2 acres it would take 80 minutes, double both of them. For 3 acres it would take 120 minutes. So it's 40 minutes per acre. So our constant proportionality, k, equals 40. Actually, that should have gone here. K equals 40. Okay, The table below shows money earned for selling different numbers of books. What is a constant for proportionality? So this is our x, and this is our y. Independent, books sold. Dependent, the money earned. The money earned is dependent on the number of books sold. So when x is, so remember we've got k equals y over x. So in this case, when y is 27, x equals 3. Or we could have said when when y equals 63, x equals 7. So 27 divided by 3, remember this fraction bar means divide. 27 divided by 3 is 9. So in this case, k equals 9. We get the same thing if we divided 63 by 7 or if we divided 90 by 10. They're all going to give us a constant proportionality, which is 9. Okay, given the equation y equals kx, where y equals 1.2 and x equals 1.5, what is the value of k? Okay, so we've got y equals kx, and we're going to substitute. So for y, I'm going to substitute 1.2, and that equals k times, for x, I'm going to substitute 1.5. So k times 1.5. Okay, now I just substituted, use that formula. Substitute 1.2 for my y and 1.5 for my k. For my x. So I don't want k times 1.5, I want k by itself. So in order to get rid of the times 1.5, you've got to divide by 1.5. But what I do to one side, I have to do to the other side to keep it equal. And this side, anything times 1.5 divided by 1.5 will cancel out. So k equals 1.2 divided by 1.5. So let's go to the calculator. 1.2 divided by 1.5. And that'll give me 8/10, 0.8. So the value of k is k equals 0.8. Now notice I also could have used this formula and I would have gotten the same thing. This got me to this. When y is 1.2, x is 1.5. So this formula is essentially the same thing as this formula. Okay, the graph below shows the proportional relationship between the number of movies downloaded and the download time. So here, let's look for some whole numbers. I got 3, and well, what are we going by here? We're going by 1, 2, 3, 4. It's cut into quarters. So when I've got 3, I've got 4 1/4. So this is our x, this is our y. So x, y. X is our number of movies, y is our time. So when x is 3, y is 4 1/4, 4.25. Let's go to here. I see this is a whole number. I got 8, and this is a whole number, 12. Let's use this. So we've got, when x is 8, y is 12. I would rather work with whole numbers. See, this is a decimal, this is a decimal, this is a decimal. These are all decimals for y except for this one. This one is a whole number for x, 8, and a whole number for y, 12. So constant for proportionality, k equals y over x. So we're going to use our whole numbers. We could use these numbers if we wanted to since we have a calculator, but let's go ahead and use the whole numbers. So k equals, when y is 12, x is 8. Okay, now we could just type this into the calculator or just divide it top in, bottom out, but we could also simplify this. Divide by 4 is 3, divide by 4 is 8. I'm sorry, 8 divided by 4 is not 8. 8 divided by 4 is 2. So 3 halves. So k equals 3 halves. Now we could go further and make that 1 1/2. Remember, that's 2 halves plus 1/2 gives us 3 halves. Or we could say k equals 1.5.